Okay, this first question is a kinetic energy one. So we have EK equals half mv squared. So it's no different to year 11. We're going to have equals half times the mass, which is some kind of huge number. What is it? 14,000 times 750 times by 14 meters per second, and that's squared. Now when you're doing that, try and make sure you square that first, the 14. And you should end up with some fairly large number. Now you can put it in kilojoules. I'm just going to write it in joules. Kilojoules would just mean that you finished at that point and you'd have 1445, say, kilojoules if you rounded it as well. That's worth an achieve. Now if you move on to B, it's got the deaccelerating. So, and there's a constant rate of deceleration. So you should be thinking about kinematics. And so you're going to have a look at the formula, and it's Vf squared equals Vi squared plus 2AD. Now, in this case, we've got the final velocity, which is going to be 4 meters per second, squared, the initial velocity, which is 14 meters per second squared, plus 2 times 1.5 meters per second times by d. So that becomes 16 equals 196 plus, well, it's going to be being a minus, so I'll just get rid of that because of the negative here. So it's going to be minus 3 times d. And that's going to end up becoming, I'm going to move this to the other side, so that becomes 3d. I'm going to move that to that side, so it becomes negative and gets taken away from the 196 equals 180, so d equals 60 meters. Now it's told you the answer, so you're just showing it. So unfortunately, that's still just worth an achieve. It would have probably been worth more if it was a kind of just work it out question. Now the bus stops, and now we get on to a spring constant question. Now it's asking you to work out the combined mass. Now in spring questions, if you look through for the formula, if you forget them and you're thinking about this, obviously that's just the amount it's extended, that's the spring constant itself, and the force is often the weight force. So the weight force is where you're going to get the mass. So at this stage, you should have some idea of the direction you're heading in answering this question. So, okay, so what is the spring constant? Well, they've told us it's 90,000 Newton meters, but there are 4 of them, so that's on each wheel, so it's times by 4, and that's going to equal some huge number as well, 360,000 Newton meters. So that's 360,000 times by x. Now x is what, 6 centimeters, the displacement. So we do need to convert that to meters. And so based on that, if we multiply those two together, we'll get the weight force, and that's going to be 21,600 newtons. Now that is the weight force. So all right. So we're going to now use F equals mg. So 21,600 newtons equals the mass times by 9.8. So if we divide that in there, we should end up with a mass of about 2,200 kgs. Now, if you just calculated, this here, that would have been an achieve. If you got this here, the force was merit. If you had a minor error in getting to here, and that would have still been merit, but if you got that answer, that was in fact an excellence. And that should be the first question.